Hello. In this lesson, we are going to study doubly linked lists. In the previous lesson, we had already seen the LQ stack, and we looked at how they handle LIFO, last in, first out, and FIFO, first in, first out. Both classes, under the hood, use the doubly linked list. Imagine an active train where each wagon is a node connected to the next carriage and the previous one. This allows us to travel the train in both directions with the same ease. Therefore, this type of list lets us have a collection of elements where each element knows what its previous and next elements are. This bidirectional nature makes it incredibly powerful and flexible. For example, in an array in PHP, to delete an element in the middle, we have to recreate the array. But with the doubly linked list, this operation is very fast. We just update the connections of the neighboring nodes. Let's look at an example in the editor. We'll create a file called playlist and explore how to use the doubly linked list to simulate a music playlist. This way, we can go to the next song, the previous song, and so on. We can create a playlist variable and initialize it. Then we can insert songs, which can be objects or arrays. For example, each song can have a name and a duration. And we can add whatever else we want. Once we've added the data, we can insert a new song at the beginning using a method that places a value at the start of the list. If we want to know what the first item in the list is, we can call a method that gives us the item at the top. When we print that, we see that the last song we added appears first. If we do the same thing using the method to get the item at the bottom of the list, we get the first song we originally added. So, using that initial method is like saying the most recent song added is the one that's now first. That's why the top gives us the last one we inserted at the beginning. There are also methods like shift, which removes and returns the first item, and pop, which removes and returns the last item. Before removing anything, we can also loop through the list. That's because the doubly linked list class implements the iterator interface, so we can use methods like current, next, and key. It also implements the countable interface, so we can count how many items are in the list. It supports array access, meaning we can access values by index, as if it were an array. And it implements serializable, so we can serialize and deserialize the list. This means we can loop through each item and display, for example, the song name. When we run it, we can see the list of songs. The first one is the most recently added at the top, followed by the others in the order we inserted them. If we then call the pop method, it will remove the last song. We can see that it's no longer in the list when we display it again. So, pop removes the item at the end, just like in a stack, where the last item added is on top and removed first. Next, if we call the shift method, it will remove the item from the beginning. In this case, that's the song we added with the earlier method to place it first. After calling shift, we'll see that only the remaining songs are still in the list. So now, with both pop and shift called, two songs have been removed from opposite ends of the list. And finally, we can check how many songs are left. Since the class implements countable, we can easily get the count. Running the program will show there are 3 songs remaining. So overall, this is a very convenient and efficient type of list. If you need to quickly add or remove elements, or access the first or last item directly, a doubly linked list is a fast and flexible solution.